Hi, Math 3 students. Today we are going to go over fractional exponents, okay? Before we get into this, I just want to review a couple of ideas. So the first idea I want to talk about is how you just deal with exponents, really. So let's say we had x to the power of a times x to the power of b, all right? When you are multiplying exponents with the same base, you add the exponents, okay? When you are dividing exponents of the same base, you subtract them. So this would be x to the power of a minus b. And then if we raise a power to a power, you multiply them. So you would get x to the power of a times b. All right, these are just rules of exponents, but I just wanted to kind of refresh your memory so that these make sense for you, okay? All right, so now we're going to kind of get into the thick of it here. So it says write the expression in radical form. So first off, what is a radical? It's this thing, okay? So something that I want you to remember, okay, and copy this down. If we have this setup here, okay? This works in both ways, okay? You can go from a radical to an exponent or an exponent to a radical, okay? Basically, whatever number is inside of the radical becomes the denominator of your exponent. Whatever x is being raised to, that becomes your numerator. If x isn't being raised to anything, so let's say we had like bx like this, that's an implied 1, okay? And that would be like x to the power of 1 over whatever b is, okay? So keep in mind, if there is no power there on the x, it's an implied 1, okay? So, for example, here on number 1, they want us to write this as a radical, so we're going to write our radical, throw an x there. The 4 in the denominator goes into my radical, and the 3 is the power on my x, and this would be my answer. All right, so this guy here, we got the square root of, the fifth root of x to the 4th. All right, let's try, sorry, I don't know why my Amazon robot is making sounds. All right, number 3 here, okay? Now they gave us the radical and they want us to write it in exponential form. So it's going to be x to the power of 2/3. This one is tricky because we know that our denominator is going to be 4, but we don't have anything here for our numerator. Remember, there's an implied 1 there, okay? And then you know what? One thing that this did not have that I want to make sure you all understand, write in one more example, okay? Let's say we had this. Okay? Something like this. If there's no number inside of the root, that is an implied 2. That's why we call it a square root. So this guy would be written as x to the power of 3/2. All right? So keep that in mind. All right? If there's nothing here, it's an implied 2. If there's nothing on the power of x, it is an implied 1. Or the variable, I guess I should say. All right, so let's go ahead and try number 5 here. So it says they want us to find the value of a. So if you recall, when we are multiplying things with exponents, or exponents with the same base, we add them. So we just need to do 2 plus 1/5, okay? I am okay with you using your calculator on this. So you could do 2 plus 1/5 on your calculator, which you end up with 11/5. I do think it's important, though, for you to know how to do this in your head. So when you're trying to add fractions, you need a common denominator. The denominator on my second fraction here is a 5, so I'm going to try and get my first guy to have a denominator of 5. So if I multiply it by 5 over 5, I get 2 times 5, which is 10, all over 5 plus 1/5. That gives me my 11/5. So what this means is that this expression is equal to x to the power of 11/5. So a is equal to 11/5. All right. For this guy, when we raise a power to a power, we multiply. 5 times 1/2 is going to be 5/2. Wow, my handwriting is so awful today. We get 5/2 equals x to the power of a. So a is equal to 5/2. Let's see. This one here. All right. When we are dividing things with exponents, we subtract. So you have to do top minus bottom. Okay. So I'm going to do 2/3 minus 3/5. Okay. So we need a common denominator. Looking at these guys, my common denominator is going to be 15. So I'm going to multiply this first fraction by 5, and I get 10/15. I'm going to multiply this second fraction by 3, so that I get 9/15, and I end up with 1/15. So my answer is that x to the power of 1/15 equals x to the a. Therefore, the value of a is 1/15. All right. Okie dokie. Something like this. It says, write this as a single radical using the smallest possible root. Okay. So what we need to do for this guy is first we should write this guy as a power. Okay. So the top value is going to be b to the power of 7/2. Remember, if there's nothing there, it's an implied 2. And then the guy on the bottom is going to be b to the power of 4/3. All right. When we do top minus bottom, we get 7/2 minus 4/3. Our common denominator is going to be 6. So we get 21/6 minus, and then 8/6, which is going to get me 13/6. Okay, so I get b to the power of 13/6. If you don't know how to add and subtract fractions, to do it on your calculator, you're going to do like 7/2 minus 4/3. That gives you a gross fraction, so you just do math enter, and you get 13/6. Okay, so at this point, you want to, if they said the smallest possible root, what you need to double check is make sure that this fraction is completely simplified. In this case, it is. And they want you to write it as a radical. So to put this guy back in a radical, you're going to do this. The 6 is going to go here, and the 13 is going to go there. All right. Let's see. Ooh, this one's tricky. Okay. So first, we've got this guy on the inside. Okay, so let's just think about how we could write him. That's going to be x to the power of 8/5. I do 8/5. Then what we have here is it's basically when you have a just root 6, basically what we're doing is raising it to the power of 1/6. Okay, so that is how you would rewrite that root 6, or sorry, not root 6, 6th root. And when we raise a power to a power, we multiply. When you multiply fractions, you just multiply across. So this would give us x to the power of 8/30. However, that is not simplified, and they said they want the smallest possible root, because if I didn't care about the smallest possible root, right, you could do like the 30th root of x to the 8th, okay? But they want the smallest, so we need to make sure we simplify our fraction. Let's see, we can divide both those by 2, so we would get 4/15, okay? So to write that guy as a, what do you call it? Radical. Sorry, it's a little bit late. To write that guy as a radical, you're going to go ahead, put your 15 in your root. Zoom in a little bit. 15 goes there. You end up with x to the 4th. All right. Let's see. Let's try this one. Okay. They want us to use the property of exponents to get the value of a. So what I would do here is this guy's already an x. I would get everything in exponential form. So we end up with x to the times x to the power of 4/3. And now this one's pretty easy, right? Remember when you multiply exponents, you add them. So we end up with x to the 5/3. So a is 5/3. All right, let's do one more. Let's do number 17. So again, they want us to write this as a single radical. The top guy can be written as x to the 2/3. The bottom guy, when you raise a power to a power, you multiply. So we're going to get x to the 4/5. When we divide powers, we subtract them. So we're going to do 2/3 minus 4/5. You're going to multiply the top and the bottom here. This guy's going to be by 5, so we get 10/15. This guy we got to multiply by 3, so we get 12/15. So I end up with -2/15. All right. So my answer is that x to the power of -2/15 is equal to x to the power of a. So therefore, a equals -2/15.